Okay, so we just talked about the definition of a function, which says that every input gives us only one output. And now we want to extend that from just looking at a t chart to looking at an actual function, or an actual graph, and deciding if it's a function or if it's not a function. So let's take a look at our canvas over here. And let me give you two examples. Again, one is going to be a function and one is not. So this is our XY chart, kind of warming up here. And we're not graphing anything too fancy right now, but let's say that I have a nice U-shaped graph. So this is called a parabola. I'm thinking you have seen this before. And then I'm also going to draw it looks like a U laying on its side here. So it's like a sideways parabola. And the question I'm going to ask is, which one of these two graphs is a function? Say function or not a function. And we're going to remind ourselves that a function has, for every time we have an input of like an x value, we get only one output. So if we ever have a situation where an input gives us one output sometimes and a different output another time, that's not a function. That would be a problem. So we only, every time we input an x, we get only one y as a result. So let's look at our examples up here, and I'm going to switch our color just so we can kind of draw on this without getting confused. We'll do blue. So remember that the horizontal axis is the x-axis. So it doesn't really matter what the values are here. I just want you to remember that like we would, well, I will label it because it helps us to see what we're talking about when we say the x values. And then likewise, we have y values along the vertical axis. And the way that a graph works is, or the way that we think about it, is that at any point along this x-axis, I could choose a number. So let's say I choose the number 2. So x equals 2. And I can ask myself, what number is 2 paired with? Just made that look very blurry. So what number is 2 paired with? And what I do is I kind of go up to my line, my graph, and I find out what y it corresponds to. So in other words, I have a y value here that corresponds with some x value down here. Again, more specifically, so if this is 1, 2, 3, 4, this point is actually the coordinate 2, 2, if you remember. So this is the x and this is the y. So that's how we think about a graph. Likewise, so I'm just going to leave that alone there. Over here on the right, same thing. Let's say I have, we'll count up to 4. 1, 2, 3, 4 here on the y. Get some negative values in there. And let's say again I choose 2 on the x. Or actually no, let's choose 3, just because I want to do something different. And if I choose the x value here on the graph, I find out where on my green graph, my green line, that x would have a value. So actually here it's kind of interesting because I have two choices, right? I could say that this x value is associated with the y value 2, so this would be 3, 2. Or I could say that it's associated with the y value of negative 2. So I have actually two choices here for what the x value is paired with in the y value. So if any of this is unfamiliar to you, this would be a great question to ask in class. This should all be review, but just in case it's not, feel free to ask. So over here we have, again, a parabola or a U-shaped graph. We're looking at an input of 2 and checking what the y output is. And over here we have an input, say, of 3, and we're checking to see what the y output is. So you probably already see where this is going. In the left graph, if I choose an x value, or at least if I choose this particular x value, it gives me one y value. In fact, it gives me the ordered pair. We call this an ordered pair. I think I said that already, but why not write it down? So this is an ordered pair. It shows us x and y. If I input a 2, I get an output of 2. Input 2, output 2. It's straightforward. I know exactly what I'm going to get out for what I'm going to put in. On the other hand, in my second example over here, if I input the value of 3, I end up with a little bit of a conundrum. If the input is 3, do I say that the output is positive 2? Because remember the y, the second one is our output. Or do I say that the output is negative 2? Which one do I say? Well, as soon as you find yourself in this issue of confusion, you know this is not a function. Not a function. On the other hand, our first example is a function because we don't have that situation. So looking in, on the left, we have an output, one output for the input of 2. On the right, I ended up with 2 different output choices, which is how I knew that it wasn't a function. Now, you may have heard this term used before. If not, I'm going to say it now. The easy way that we test a graph to find out if it is a function is by something that we call the vertical line test. This is all that it means. If I can look at a graph and draw a bunch of vertical lines and they only ever cross the line once each, then it's a function. But if I can draw a vertical line that would overlap the graph to more than one time, so it doesn't even matter if it's 2, if it overlaps more than one time, it fails the vertical line test and it's not a function. Now, if you need to see that, if you're a visual person, let me show you what that looks like in an actual example. So, coming back to our canvas. A graph that passes the vertical line test might be something like this. Oh, I just want to use a different color. So here's my graph. Goes up, it comes down, it goes up again, it bounces off the x-axis, and it goes all the way down. Okay, that's our function. Weird function. There actually really are functions that look like that, and you will find out how to create them before the year is over. Is this a function? And I'm going to tell you ahead of time, yes it is. Now how do I know? Does it pass the vertical line test? And again, that just means if I were to take a line anywhere and just draw it vertically means up and down, right? Draw it anywhere, up and down, up and down, up and down. I'm asking myself, would I ever be able to draw a vertical line that would overlap this graph more than once? And the answer is no. Everywhere that I've drawn this line, draw these lines, notice that it only crossed one time. Like different places, right? But each vertical line only overlapped the graph one time. So it passed the vertical line test, which means that it is a function. Now, if you're wondering what it would look like for it to fail, let's look at another example. So again, here are our x and y axes. And let's say that our graph looked like this, which is supposed to be a circle. You can pretend it's a circle. Does it pass the vertical line test? In other words, if I draw a line anywhere on this page, oops, that is a very vertical line, or a diagonal line, not a vertical line. So if I draw a vertical line here, 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 anywhere along this section, the question is, does it ever cross more than once? And unfortunately for this beautiful squished circle, the answer is yes, it does. Pretty much almost everywhere that the lines touch this graph, it overlaps twice. This means that it fails the vertical line test, which means it is not a function. So that is the simple way that we test whether graphs are functions or not functions. It's how we figure out whether or not that input value of an x value is going to give us more than one output, because the fact that it crosses at more than one location when you draw that vertical line is telling us that there are going to be multiple outputs every time we have an input of an x value. All right, so now we've talked about what it takes to be a number relation or a number relationship. Then we've talked about what it takes for that relation to be considered a function. And now, before we finish, we want to talk about how to look at a function that's written maybe as a t-charts or as a bunch of ordered pairs, and how to write that function in the form of an equation. So that's our final topic for this lesson. So take a listen to that and then you will be done.